Hello everyone, I am Dr. Naresh Kumar, working as an assistant professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about series combination and parallel combination for resistors, inductors and capacitors. That means RLC parameters. So these are my lecture outlines. So first I will define series circuit definition. First, I will define series circuit definition. Next, series circuit examples. Next, characteristics of series circuit. Next, series resistors, series inductors, series capacitors. In that, R equivalent derivation, L equivalent derivation, C equivalent derivation. Next, parallel circuit definition, parallel circuit examples, parallel circuit characteristics. That means properties. Next, parallel circuit resistors, inductors and capacitors. In that, R equivalent derivation, R equivalent L equivalent derivation and C equivalent derivation. We will solve some problems also based on series parallel combination for resistors, inductors and capacitors. Everything in detail we are going to discuss in this video lecture. So first, here what is meant by series circuit? So in this series circuit, so here three elements are connected. So three elements are connected means, so elements connected one after another, see in the same line. So here three resistors R1, R2 and R3 are connected in series means, so first here, so first element second end is connected to second element first end, and second element second end is connected to third element first end, and third element second end is connected to fourth element first end. Like this, elements are connected in the chain manner in the same line. If you see the definition here, so a series circuit is a one in which components are connected end to end circuit will have only one path through which electric current flows. So in another way we can define series circuit. So here series circuit is a one in which several components are connected one after another in the same line, means same current flows to the each elements. So what are the example? If we talk about the examples, the best example for series circuit is a string of Christmas lights. So in that string of Christmas lights, so here you can see the real picture. So in this, so string of Christmas lights. So this is the string of Christmas lighting system. So in this series, three bulbs are connected in series. So here supply battery is connected to this series circuit. So in this, so first negative terminal of the battery, electrons flows from negative terminal of the battery to the positive terminal of the battery. So here any one current flows in this direction. So now if any one of the bulb fails, breaks down, broken out or missing, so what will happen to the circuit? So what will happen to the circuit? So there is no path for electrons because it will be open circuit. So it will be open circuit means no electrons flows from negative terminal of the battery to the positive terminal of the battery. So here no current flows in the circuit. No current in the flows in the circuit means no other bulb will glow on. So next, what are the, if we talk about the characteristics of series circuits. So what are the series circuit properties? So first here, if you see the diagram here in this, so first, so these are the three resistors. So R1, R2 and R3. Here I consider only resistors. So it can be applicable for inductors and capacitors also. So three resistors R1, R2 and R3 are connected in series. So here's that this one is connected across the supply voltage V and total current is the I. So each resistor currents are IR1, IR2 and IR3 and voltages are VR1, VR2, VR3. Here now here in this series connection, first property, that one is same current flows to the each element. So here, so this is the first property, same current flows to the each element. So IR1 equals to IR2 equals to IR3, that current equals to supply current, so that equals to I, this one. Next, second property is the supply voltage equals to sum of the individual voltages. Supply voltage equals sum of the individual voltages means, so V equals to the supply voltage equals to VR1 plus VR2 plus VR3. If you apply KVL also, it will be satisfied. This is second property of series circuit. Next, R equivalent equals to R1 plus R2 plus R3 till Rn. If n number of resistors are connected in series, so equivalent resistance equals to sum of the individual resistances. This is third property. Next, fourth property, if it is capacitor, inductors are connected in series. So in that case, L equivalent equals to L1 plus L2 plus L3 till Ln. Equivalent inductance equals to sum of the individual inductances. This is fourth property. And fifth property is the, so reciprocal of equivalent capacitance equals to sum of the reciprocal of individual capacitances. This one is the fifth property. So 1 by C equivalent equals to 1 by C1 plus 1 by C2 plus 1 by C3 till 1 by Cn. Next, here if you observe the third equation, so here R equivalent is always greater than R1, R equivalent is always greater than R2, and R equivalent is greater than R3. So from this we can say, so R equivalent is the largest of all individual resistances. Same fashion here, this is sixth property. Next, L equivalent is the largest of, this is seventh one, L equivalent is the largest of all individual inductances. Next, so C equivalent is the smallest of, C equivalent is always less than C1, C equivalent is always less than C2, C equivalent is always less than C3. This is eighth one. So C equivalent is the smallest of individual capacitances. Now here, so before moving to the further discussion on series, parallel, R equivalent, L equivalent, C equivalent derivation. So here we must have a prior knowledge on voltage current relationships for RLC parameters. Here voltage across, Ohm's law means voltage across any element is directly proportional to the V is directly proportional to the current. So here for resistors V is equal to IR. For resistors V is equal to IR. So here I equals to V by R, current. So next, in case of inductors, voltage is directly proportional to the derivative of current. So V, in case of inductors, voltage is directly proportional to the di by dt. So here L is the constant, V equals to L di by dt. So for this case, current case, I equals to 1 by L integral of V dt. Next, for capacitor case, V is directly proportional to the integral of I dt. Now here in this, V equals to 1 by C integral of I dt. So current equals to I equals to C dV by dt. So this one. So now let us move to the series resistors. In that R equivalent resistance derivation. So series resistor. So three resistors R1, R2 and R3 are connected in series. So the whole circuit is connected across the supply voltage V here. So and current drawn by the circuit is I. If you give the battery to the three resistors here, current is flowing. It is a closed path. So the current drawn by the circuit is I. So here current flowing through the each resistor. So current flowing through the resistor R1 is the IR1. Current flowing through the resistor R2 is the IR2. Current flowing through the resistor R3 is the IR3. Next, voltage across the resistor is VR1. Voltage R1 is the VR1. Voltage across the resistor R2 is the VR2. Voltage across the resistor R3 is the VR3. Here we know that Ohm's law, V is equal to, Ohm's law means voltage across any element is directly proportional to the current. So V is equal to IR here. If you apply Ohm's law for this particular resistance R1 here, so V equals to VR1 equals to this VR1 equals to R1 into IR1 into R1, this one. Next, VR2 equals to IR2 into R2. Next, VR3 equals to IR3 multiplication of R3. Next, if you consider these three resistors as a single equivalent circuit, that is R equivalent, that one equals to, so the if you apply for that, so V equals to R equivalent multiplication of I, V equals to I into R equivalent. Now we know that series connection second property, so supply voltage equals to sum of the individual resistive drops. So here V equals to VR1 plus VR2 plus VR3. So now here, so VR1, we know that VR1 equals to this one, VR1 equals to this one, and VR2 equals to IR2 R2, and VR3 equals to IR3 R3. Now V equals to I into R equivalent. Now if you substitute this four formulas in this, so it will V equals to IR1 into R1, VR2 equals to IR2 into R2 plus VR3 IR3 multiplication of R3. Now here series connections first property, same current flows to the each element, that current equals to supply current, IR1 equals to IR2 equals to IR3, that equals to total current I. So now here, so that for that case IR1 is I, IR2 is I, and IR3 is I. So I final equation IR equivalent is equals to IR1 plus IR2 plus IR3. So now here in the RHS side, I is the common term, you can take a common. So I R equivalent is equals to I into R1 plus R2 plus R3. In the LHS and RHS, so here I is the common term, so you can cancel it. So final equation, so R equivalent equals to R1 plus R2 plus R3. So this formula is only for 3 number of resistors connected in series. So if suppose n number of resistors which are connected in series, means for that case, so R equivalent equals to R1 plus R2 plus R3 till Rn. So from this we can say that, so equivalent resistance equals to sum of the individual resistances. So if n number of resistors are connected in series, but all elements having same resistance value, for that case, so R equivalent is equals to N into R. So all resistance R1 equals to R2 equals to R3 equals to Rn, that equals to completely R. So for that case the formula is R equivalent equals to N into R. N is the number of elements. So now let us move to the series inductors. So here 3 inductors. So 3 inductors L1, L2 and L3 are connected in series. The whole circuit is connected across supply voltage E. If you give the supply voltage battery to these 3 inductors, series inductors, so current flows in the circuit. There is a closed path. So that current drawn by circuit, total current is the I. So each inductor carries the current. So here, so L1 current is the IL1, L2 current is the IL2, L3 current is the IL3. Now voltage across inductor L1 is the VL1, voltage across inductor L2 is the VL2, voltage across inductor L3 is the VL3. Now according to the Ohm's law, V is directly proportional to the derivative of current. So in this case V equals to L di by dt. So for this particular case VL1 equals to L1 into dIL1 by dt, L2 equals to dIL2, VL2 equals to L2 dIL2 by dt, VL3 equals to L3 dIL3 by dt. So these are the 3 formulas. Next, if you consider these 3 inductors as a single inductance, so for that case that means L equivalent. So for that case V is equal to L equivalent into di by dt, this one. Now we know that series connection second property, supply voltage equals to sum of the individual voltages. So for that case V equals to VL1 plus VL2 plus VL3. Now here VL1 is this formula, VL1 equals to L1 dIL1 by dt, VL2 equals to L2 dIL2 by dt, VL3 equals to L3 dIL3 by dt, and V equals to L equivalent di by dt. Now substitute in this equation. So here L equivalent di by dt, L1 dIL1 by dt plus L2 dIL2 by dt plus L3 dIL3 by dt. But here same current flows to the each inductor because they are connected in series. So here IL1 equals to IL2 equals to IL3, that equals to total current I. So now here this one. Now you can write this in place of IL1. So in place of IL1, you can write I in place of IL2. You can write I in place of IL3. You can write I. So here L equivalent di by dt plus L1 di by dt plus L2 di by dt plus L3 di by dt. So in the RHS set, the common term is the di by dt. So you can take the common. So L equivalent di by dt, that equals to L1 plus L2 plus L3 di by dt. Here the common term in the LHS and RHS is the di by dt. You can cancel it. So final equation, L equivalent equals to L1 plus L2 plus L3. So this formula is only for three inductors connected in series. So if n number of inductors are connected in series, so n number of inductors are connected in series means L equivalent equals to L1 plus L2 plus L3 till Ln. So if same number of inductors are connected in series, n number of inductors which are having same value, for that case L equivalent equals to n into L. That same value is the L. Next, if you see the series capacitors. So series capacitors means, so three capacitors. So three capacitors means C1, C2 and C3. Three capacitors connected in series. The whole circuit is connected across supply voltage V. So now current drawn by the circuit, total current is the I. So each capacitor is carrying current. So that is I1, IC1, IC2 and IC3. So IC1 is the C1 current, IC2 is the C2 current, IC3 is the C3 current. Next VC1 is the C1 voltage, VC2 is the C2 voltage and VC3 is the C3 voltage. So we know this formula, V equals to 1 by C integral of I dt. So for this particular case voltage current relation, so here VC1 equals to 1 by C1 integral of IC1 dt, VC2 equals to 1 by C2 integral of IC2 dt, VC3 equals to 1 by C3 integral of IC3 dt. Now if you consider these three capacitors as single equivalent circuit, single equivalent capacitance, that is C equivalent. So for that case, so V equals to 1 by C equivalent I integral of I dt. So this one formula. Now here series connection, second property, same thing. Supply voltage equals to sum of the individual capacitive voltages, that equals V equals to VC1 plus VC2 plus VC3. Now here VC1 is 1 by C1 IC1 dt. That so this one VC1 is the 1 by C1 1 by C1 integral of IC1 dt. VC2 is the 1 by C2 integral of IC2 dt, and VC3 is the 1 by C3 integral of IC3 dt, and V is the 1 by C equivalent integral of I dt. But here series connection, first property, I equals to IC1 equals to IC2 equals to IC3, same current flows to the each element, that current equals to supply current. Now here supply current means, here you can replace this IC1 I, IC2 I, IC3 I. Now 1 by C equivalent integral of I dt is equals to 1 by C1 integral of I dt plus 1 by C2 integral of I dt plus 1 by C3 integral of I dt. Now here the common term in the RHS side, so integral of I dt, you can take that one as common. So in this, so integral of I dt, 1 by C1 plus 1 by C2 plus 1 by C3 integral of I dt, that equals to 1 by C equivalent integral of I dt. So here in the LHS side and RHS side, the integral of I dt is the common. So you can cancel it. So 1 by C equivalent equals to 1 by C1 plus 1 by C2 plus 1 by C3. Now if n number of, this formula is only for three capacitors which are connected in series. So if n number of resistors are connected in series, so for that case 1 by C equivalent equals to 1 by C1 plus 1 by C2 plus 1 by C3 till 1 by C1. But if C1, C2 and C3 till Cn all are same values, that value is C, same capacitance, same capacitor, same number of capacitors, n number of capacitors connected in series. For that case C equivalent equals to C by N. So in the C by N. C equivalent equals to C by N. Now, moving on to the parallel circuit. So, parallel circuit. What is meant by parallel circuit? So, parallel circuit means, if you see here, so parallel circuit, three elements. So, parallel circuit is said to be means here. So, one end of each element is connected to one point and other end of each element is connected to other point. So, such connection is known as parallel connection. Here, each element having 2 points, 1, 2, 1, 2. So, here each element first end is connected to one point here and each element second end is connected to other point. So, this connection is known as parallel connection. If you see the definition, parallel connection is a one in which the end of each of the component have common point. So, this one, this is a common point. Next, and other ends are connected to another common point. So, this one. So, now this circuit is parallel circuit. Now, what are the example? If you talk about the examples, so street lighting system is the best example for parallel circuit. So, here street lighting system. So, if you see this parallel circuit, so in this parallel circuit, so three bulbs are connected in parallel, three lights are connected in parallel. So, that is connected across supply. Okay. So, here if any one of the bulb fails, if any one of the, suppose second bulb fails, what will happen to the circuit? Nothing will happen to the circuit. Each light having its own individual circuit, same voltage developed across each element. So, other bulbs also will function. Next, properties, characteristics of parallel circuit. So, here three resistors. Here I considered only three resistors. So, three resistors means it can be applicable for inductors and capacitors also. R1, R2 and R3 are connected in parallel. Next, that supply voltage, that parallel circuit is connected across supply voltage and this is total current. These are the dividing currents, IR1, IR2 and IR3. Next, VR1, VR2, VR3 are voltages across the resistors. So, parallel circuits first property is the same voltage developed across each element. That voltage equals to supply voltage. VR1 equals to VR2 equals to VR3 equals to supply voltage V. Same voltage developed across the each element. Next, supply current equals to sum of the individual currents. So, parallel branches current, sum of the parallel branches current. If you apply KCL at this node also, it will be satisfied. Sum of entering currents equals to sum of leaving currents at a node. So, at this node, entering current is I and leaving currents are I1, I2 and I3. Now, here this one is the second property. I equals to IR1 plus IR2 plus IR3. Next, third one. So, R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3 till 1 by Rn. This one is the third property. Reciprocal of equivalent resistance equals to sum of the reciprocal of individual resistances. Next, fourth one. Reciprocal of equivalent inductance equals to sum of the individual reciprocal of individual inductances. So, 1 by L equivalent equals to 1 by L1 plus 1 by L2 plus 1 by L3 till 1 by Ln. So, next capacitors case. So, C equivalent equals to C1 plus C2 plus C3 till Cn. C equivalent equals to equivalent capacitance equals to sum of the individual capacitances. Now, from this here, so R equivalent is the smallest of individual resistances. So, R equivalent is less than R1, R equivalent is less than R2 and R equivalent is less than R3. Now here L equivalent is also smallest of individual inductances. L equivalent is less than, this is the sixth one and this one is the seventh one. This one is the seventh one. Next, C equivalent is the largest of individual capacitances. This one is a 8 one. Next, parallel resistors. Parallel resistors means, so three resistors R1, R2 and R3 are connected in series. The whole circuit, that total circuit is connected across the supply voltage V. Now current drawn by total current is, there is a closed path, current flows in the circuit. Now here currents will divided in the parallel branches, so that currents are IR1, IR2 and IR3. IR1 is the current in R1, IR2 is the current in R2 and IR3 is the current in R3. Next, VR1, VR2 and VR3 are voltages across R1, R2 and R3 respectively. Next, here Ohm's law. So in the series resistor, we considered only voltage V is equal to IR. Here currents, in the parallel case currents, so I equals to V by R. So this formula, Ohm's law, I equals to V by R. Now here this IR1 equals to VR1 by R1, VR2 by IR2 equals to VR2 by R2 and IR3 equals to VR3 by R3. So these are the three formulas. If you consider these three parallel resistors as a single R equivalent, so that is R equivalent is equal to I equals to V by the supply voltage. This I equals to this the supply voltage divided by this R equivalent. So now here parallel connection, second property is the supply current equals to sum of the individual currents. So that I equals to IR1 plus IR2 plus IR3. Now here this IR1 is the this one VR1 by R1. So if you substitute in this, so IR1 is the VR1 by R1 this one, IR2 is the VR2 by R2 this one and IR3 is the VR3 by R3 this one. Next, I equals to V by R equivalent. Now here VR1 equals to VR2 equals to VR3. Same voltage developed across the each element. So that is parallel connection first property. So in that case, so VR1 equals to VR2 equals to VR3. Same voltage. That voltage equals to supply voltage. So now here, so if you substitute, you can write here VR1 equals to V, VR2 equals to V and VR3 equals to V. And this is supply voltage V. In the RHS set, the common term is the V. You can write this equation as this one. This is the common term in the RHS set. So here V is a common term for LHS and RHS. So you can simplify this. 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this formula is only for three resistors are connected in parallel. Three resistors are connected in parallel. So in that case, if n number of resistors are connected in parallel, so 4 number of 5 number, 6 number, n number of resistors are connected in parallel. So for that case, so 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3 till 1 by Rn. If suppose n number of resistors are connected in series which are having same value, that value is R, same resistance R. So for that case, R equivalent equals to R by N. Now moving on to the parallel inductors. So three inductors. So three inductors are connected in series. Sorry, not parallel. Three inductors are connected in parallel. The whole circuit is connected across supply voltage V. So next current flowing through this circuit is I. The total current is the I. So here L1, L2 and L3 also carrying current. That currents are IL1 is the L1 current, IL2 is the L2 current and IL3 is the L3 current. VL1 is the voltage across inductor L1, VL2 is the voltage across inductor L2 and VL3 is the voltage across inductor L3. Now we know the formula I equals to 1 by L integral of V dt. So IL1 equals to 1 by L integral of VL1 dt. IL2 equals to 1 by L2 integral of VL2 dt. IL3 equals to 1 by L3 integral of VL3 d3. Now here, if you consider these three inductors are considered as single value, L equivalent. So for that case, I equals to 1 by L equivalent integral of V dt. So this one. Now parallel connection, second property, supply voltage equals to sum of the individual, not supply voltage, supply current equals to sum of the individual currents, that equals to I equals to IL1 plus IL2 plus IL3. You can substitute these four formulas in this. So now if you substitute in this, so 1 by L equal, I equals to 1 by L equivalent integral of V dt. IL1 is the 1 by L1 integral of VL1 dt. IL2 is the 1 by L2 integral of VL2 dt, and this IL3 is the 1 by L3 integral of dt. This is this one and this one and this one. Now here same voltage developed across the each element, so that voltage equals to supply voltage. You can write this one as a V, and you can write this one as a V, and you can write this one as a V. So now here same voltage, VL1 equals VL2 equals VL2, that equals to supply voltage V. So here this is V, this is V, this one is V. Now common term in the RHS side, so integral of V dt. So in the LHS and RHS side, is the common term is the integral of V dt. So 1 by L equivalent equals to 1 by L1 plus 1 by L2 plus 1 by L3. So this is only for three number of inductors are connected in parallel. If n number of inductors are connected in parallel, so for that case 1 by L equivalent equals to 1 by L1 plus 1 by L2 plus 1 by L3 till 1 by Ln. So now here same number of inductors, same value of inductors are connected in parallel. That number is n. N number of inductors are connected in parallel, which are having same value. For that case, L equivalent equals to L by same value is L. So now here parallel capacitors. So three capacitors C1, C2 and C3 are connected in parallel. The whole circuit is connected across supply voltage V, and here I is the current drawn by the circuit. Currents in each circuit is IC1, IC2 and IC3. So C1 is the C1 current, IC2 is the C2 current, and IC3 is the C3 current. Next VC1, VC2 and VC3 are the C1, C2 and C3 voltages respectively. Now here Ohm's law, I equals to C dV by dt. Now here IC1 equals to C1 dV C1 by dt. IC2 equals to C2 dV C2 by dt. IC3 equals to C3 dV C3 by d3. And these three capacitors are considered as a single equivalent. So I equals to C equivalent dV by dt. Now here parallel connection, second property equals to supply current equals to sum of the individual currents. I equals to IC1 plus IC2 plus IC3. Now here IC1 is this formula, and IC2 is this formula, and IC3 is this formula, and I equals to this formula. Now you can substitute here. So C equivalent dV by dt plus is equal to C1 dV C2 by dt plus C2 dV C2 by dt plus C3 dV C3 by dt. Now here parallel connection, first property, same voltage developed across each element. VC1 equals to VC2 equals to VC3. That voltage equals to supply voltage. So V equals to VC1 plus VC1 equals to VC2 equals to VC3. Now you can substitute in place of VC1 V, VC2 V, VC3 V. So the common term in the RHS side dV by dt. So you can write this equation as, so C equivalent dV by dt is equal to C1 dV C1 dt plus C2 dV C2 by dt. This is C3d. In that, this is VC1 is this one, VC2 is this one, and VC3 is this one. The common term is, so C1 plus C2 plus C3 dV by dt, C equivalent dV by dt. The common term for LHS and RHS is the dV by dt. So final equation C equivalent equals to C1 plus C2 plus C3. If n number of capacitors are connected in series parallel, so for that case C equivalent equals to C1 plus C2 plus C3 till Cn. So equivalent capacitance equals to sum of the individual capacitances. So if n number of capacitors are connected in series but same which are having same capacitance value, that value is C, for that case C equivalent equals to n into C. This one. Now here coming to the conclusions. So here, so series circuit, parallel circuit, series resistors, series inductors, series capacitors, parallel resistors, parallel inductors, and parallel capacitor. So here R equivalent. So equivalent resistance equals to sum of the individual resistances. Here equivalent inductance equals to sum of the individual inductances. Here equivalent capacitance, reciprocal of equivalent capacitance equals to sum of the reciprocal of individual capacitances. Here reciprocal of equivalent resistance equals to sum of the reciprocal of individual resistances. Here reciprocal of equivalent inductance equals to sum of the reciprocal of individual inductances. So here C equivalent capacitance equals to sum of the individual capacitances. Now moving on to the problems. So here now let us take one problem here. For this particular circuit, determine equivalent resistance between this source terminal. So between these two terminal. So solution is, so here. So starts from last end first. Starts from last end here. So here these three resistors are connected in series. Now here, so these three resistors are equals to 5 plus 10 plus 15. 5 plus 10 plus 15 means this value is 30. So now you can replace this one as a single equivalent. This value is 30. So now here this is 30. Now these two resistors are connected in parallel. So in that case, so R equivalent equals to 1 by R. Parallel case, reciprocal of R equivalent equals to sum of the reciprocal of individual resistance. So for this case, R equivalent equals to R1 multiplied with R2 divided by R1 plus R2. In that case, so 20 multiplication of 30 divided by 20 plus 30. So now here 600 divided by 50. So that value is 12. This is 12. Now here this one is 12. Now again these three resistors are connected in series. So for this case, R equivalent is equal to 10 plus 12 plus 8, 20, 30. This value is 30 ohms. Now, so if you replace this series combination with single equivalent circuit, that is R equivalent, so that is 30. Again this 30 and 30 R equivalent equals to 30 multiplied with 30 by 30 plus 30. So 900 by 60. That value is 15. Now here these three are connected in series. So for that case, so the R equivalent is equals to 20 plus 15 plus 40, that equals to 75 ohms. So equivalent resistance between source terminal is a 75 ohms. Now next problem on series parallel mixed combination inductances. So here same values but inductance. These three are connected in series. So 5 plus 10 plus L equivalent equals to 5 plus 10 plus 15, that value is 30. Next 20 and 30 are connected in parallel. So 20 into 30 divided by 20 plus 30, 600 divided by 50, that equals to 12. Next, these three are inductors are connected in series. So 10 plus 10 plus 12 plus 8, that means 30, L equivalent, this L equivalent. Next, these two are 30 and 30 are connected in parallel. So 30 into 30 divided by 30 plus 30, that is 15. Now these three are connected in series, 20 plus 15 plus 40, that equals to 75 millihenries, that L equivalent. Equivalent inductance between source terminal is the 75 millihenries. Now determine equivalent capacitance between source terminals. Here these three capacitors, if you solve this, so for these three capacitors, C1, this is C1, this is C2 and this is C3. So 1 by C equivalent, in case of series capacitors, 1 by C equivalent plus 1 by C1 plus 1 by C2 plus 1 by C3. So 1 by 3 plus 1 by 3 plus 1 by 3, 1 by C equivalent. So C equivalent equals to 3 by 3, C equivalent equals to 1 only. 1 by C equivalent equals to 1 only. Now, so this C equivalent we can replace as a 1. So 2 and 1. So these two capacitors are connected in parallel. So parallel case, C equivalent equals to C1 plus C2. So 2 plus 1, that equals to 3 microfarads. So this you can replace as a 3 microfarads. Next, again these three. So 1 by C equivalent equals to 1 by 3 plus 1 by 3 plus 1 by 3, that equals to 3 by 3, 1 by C equivalent. So C equivalent equals to 1 microfarads. So you can replace this and 1 microfarads, and these two are connected in parallel. So 2 plus 1 is the equivalent capacitances. Now again these three. So 1 by C equivalent equals to 1 by C1 plus 1 by C2 plus 1 by C3, that equals to 1 by 3 plus 1 by 3 plus 1 by 3. So 1 by C equivalent. So C equivalent is equal to 3 by 3. So C equivalent equals to 1. This one. So equivalent capacitance between source terminals are 1 microfarads. Now next problem. So these are the three similar circuit, only one difference for each circuit here. So determine R equivalent between these two terminals. So here these two are connected in series and these two are connected in series. Again the two equivalent resistance are connected in parallel. So here 60 plus 40, 60 and 40 are connected in series, and 20 and 30 are connected in series, and the whole combination parallel. Next, here 40, this is 100 and this one is the 50. Now here, so 100 into 50 divided by 100 plus 50, 5000 divided by 150, that equals to 500 divided by 50. Next case, this R equivalent equals to 500 divided by 15 ohms. Next case, so here only one difference is these two terminals. These two terminals are short circuited here. So if these two terminals short circuited means what will happen to the circuit? So what will happen to the circuit? So this is the redundant branch. Short circuit resistance value is 0. So redundant branch, any element across the short circuit is a completely short circuit. So here it looks like this. So this is the short circuit. This is the 20 plus 30, that is 50, and this is 100 60 plus 40, that is 100. So across this resistor, one is short circuit, means completely short circuit. This short circuit and across this resistor means completely short circuit. So this is completely short circuit, means R equivalent is the 0. For this second case, R equivalent is the 0. Next, only one modification, the short circuit occurs between these two terminals. So what will happen at this particular case? So now here, so these two are connected in parallel and these two are connected in parallel, again series connection. So in that case, so parallel connection means one end of each element is connected to one point and other end of each element is connected to other point. This is considered as this point. So now here at this case, so 60 parallel with 20 parallel plus series combination 40 plus 40 parallel with 30. So 60 into 20 divided by 60 plus 20 plus 40 multiplied with 30 divided by 40 plus 30. Here 1200 divided by 80. Sorry, not 80, 40. 1200 divided by 80 and 1200 divided by 70. So if you simplify this one 1200 into 7 plus 1200 into 8, so that is 1200 into 15 divided by 5600. So this is the R equivalent. Now here these are the three different cases. Another two different cases are, so here R equivalent between these two terminals. So this circuit, you can pull this one, this is this one, and here this one. Same circuit. These two are connected in series and these two are connected in parallel. Now here again connected in, these two are connected in series, these two are connected in series. Next, parallel connection. Next, in this case, you can pull this one and this one here. Next, these two are connected in series and these two are connected in series. Next, again parallel connection. Next case. Now here total 7 combinations. So first one is this one, there is no short circuit. Here vertical short circuit, here horizontal short circuit, here terminals are inside, here terminals are inside, like this and like this. Here this 1, 2, 3, 4, 5, 6th and 7th cases are different cases. Here this is not the short circuit and this is not the short circuit. There is a resistance value 10 ohms and there is a resistance ohms 10 ohms. In that case, so we cannot determine resistors are connected in series or resistors are connected in parallel. For that case, we will go for star to delta and delta to star conversion, that I will explain in the next lecture. I hope all these things are clear to you. If you have still any doubts, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.